Now we can see about the introduction to DSP. In this section, we can see the overview of today's section, that is objective of the subjects, outcome of the subjects, unit 1, that is the syllabus, review of signals and systems and the concept of frequency in discrete time signals. And next one is the summary of analysis and synthesis equation for DFFT and DTFT and the basic signal representation, and last one is the introduction to DFT. And the objective of the subject, it is to learn the discrete Fourier transform, properties of DFT and its application to linear filtering, to understand the characteristics of digital filters, design digital IR and FIR filters and apply their filters to filter undesirable signals in various frequency bands, to understand the effects of finite precision representation on digital filters, and to understand the fundamental concept of multirate signal processing and its applications, and to introduce the concept of adaptive filters and its applications to communication engineering. And the outcome of the subjects to apply is, the first one is to the students can able to apply DFT for the analysis of the digital signals and system, design IR and FIR filters, characteristics the effect of finite precision representation on digital filters, and they can design the multirate filters, and they can apply adaptive filter appropriately in communication systems. This is the syllabus for the first, that varies with time, space or any other independent variable, and the types of signal, continuous time signal and discrete time signal. First we can see what is by continuous time signal. Continuous time signal, these are the example, this the figure shows the examples of continuous time signal. Continuous time signals are continuously vary in accordance with time, and the continuous time signals are continuously in amplitude and time, and they are denoted by x of t. That is the examples of sine wave and cos waves. Next one is discrete time signal. Discrete time signal is defined as at discrete instant of time, and they are known as discrete time signal. The discrete time signals are continuous in amplitude and discrete in time, and they are denoted by x of n. Examples are the electrical signals derived in proportion with the physical quantities such as temperature, pressure, sound, etc. Now we can see about systems. Here the system is defined as physical device that generates a response or an output signal for a given input signal. This is the diagram shows the system. The input are x of t and the output is y of t, and the types of systems are continuous time system and discrete time system. Types of continuous time system. The types of systems are continuous time systems and discrete time system. Here, in the case of continuous time signal system, if the system that can operate only the continuous time signals are said to be the continuous time systems, and the discrete time system, the system that can operate only that can perform the operation by using the discrete times, it is said to be discrete times, equal to a cos omega t plus phi. It varies from t varies from minus infinity to infinity, and the discrete time signal x of nt equal to a cos omega nt plus phi, where n varies from minus infinity to infinity. Fourier. Now we can see about Fourier transform, that is discrete Fourier transform. Fourier transform, it is a bridge from discrete time domain to frequency domain, and the DTFT and FT are arbitrary, that is that can changes the sequence, whereas the DFT can be applied only to finite length sequence. Next one is we can see what is meant by the Fourier transform, that is analysis equation. The Fourier transform analysis equation for the signal x of t is defined as x. By using the equation we can represent this signal x of t by using the Fourier analysis, where t is the time index to time which in with units of seconds, that then f is an index to frequency with units of cycles per seconds. Synthesis equation, the frequency, the Fourier synthesis equation for the signal x of s is defined as, this is the equation for that is the synthesis equation by using the Fourier transforms. Next one is discrete time Fourier transform. The discrete time Fourier transform is the transformation that signals x of n into a complex valued function of a real variable omega, that is x of omega can be represented by using the equation. Synthesis equation, this is the signal synthesis equation, that is the synthesis equation of DTFT. Now we can see the basic signal representation. In discrete time signal processing, we use some different types of signal representation: unit step response, unit impulse response, ramp sequence, exponential sequence. The above four signals is represented by using continuous form as well as in discrete form. Here, this is the unit step representation. It is denoted as u of t equal to 1 for t greater than or equal to 0 and 0 for t less than 0. This is the representation of the continuous time signal. And here this is the discrete time sequence, unit step representation of discrete time sequence, where u of n equal to 1 for n greater than or equal to 0 and 0 for n less than 0. This is the representation of discrete time sequence. And unit step sequence, unit impulse function, it is represented by del of t equal to 1 for t equal to 0 and 0 for t not equal to 0. This is the representation for unit impulse by using continuous signal. And here in the case of discrete time sequence, the impulse response is given as del of n equal to 1 for n equal to 0 and 0 for n not equal to 0, and this is the representation. RAM sequence. The RAM sequence is defined by R of t, where R of t equal to t for t greater than or equal to 0 and 0 for t less than 0, and this is the representation in the case of continuous time signals. And next one is the discrete time sequence. R of n equal to n for n greater than or equal to 0 and 0 for n less than 0. This is the representation in the case of RAM signal. This is the next one is the exponential signal is defined as g of t equal to a into e power bt for a, where a is greater than 0, and this is the representation in the case of exponential signal. And the discrete sequence, it is denoted as g of n equal to a into e power b power n, a greater than or equal to 0. This is the representation in the case of exponential, that is discrete time signal in the case of exponential signal. Next one is discrete Fourier transform. The discrete Fourier transform that converts a finite sequence of equally spaced samples of a function into a same length sequence of equally spaced samples of the discrete time Fourier transform, which is a complex valued function of frequency. The DFT is said to be a frequency domain representation of the original input signals. And here the DFT pair can be represented by using this equation, that is DFT of x of n equal to x of k for summation n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n, while k varies from 0 to n minus 1 on IDFT x of k equal to x of n equal to 1 by n, summation k equal to 0 to n minus 1 x of k into e power j 2 pi n k by n, where n varies from 0 to n minus 1. I hope you already understood the introduction of DSP.